From the beautiful studios of Way Happy, this is Mr. Meyer, and we are talking accumulation. So let's go ahead and get started. Example number 1, find the numbers b such that the average value of this function, now average value of a function, that was average value. Take the integral of that function and then divide it by the width of that integral that you take. And make that equal to 3. Alright, so let's set it up. So first I'm going to take the integral from 0 to b, it says. They didn't give us a number this time, just a variable b. And of the function, what is that? 2 plus 6x minus 3x squared dx. Now that's the integral, that's the net accumulation of that entire function, and now I'm going to divide it by, or multiply by 1 over, right? So a lot of times if you see the 1 over, you know that's what they're talking about, average value. But I'm just going to divide it by b minus 0, because b is probably the bigger one, right? So b minus 0. So there is the average value, and I'm going to set that equal to 3. All right, nice little equation set up, and I kind of know what it means. I better know what it means. It's saying that I have this net accumulation, and I'm going to find the average value by dividing by how wide the interval is, and then I'm setting that equal to 3. And so let's go ahead and solve. First thing, I don't like this denominator, b. I'm going to move it to the other side. So 0 to b of 2 plus 6x minus 3x squared dx is equal to 3b, and now we can go ahead and hopefully integrate, right? So if I integrate that from 0 to b, let's go up a power, so that would be 2x. Let's go plus, and then we go up a power and divide, so that's 3x squared. And then we're going to go up a power and divide, so minus x cubed, evaluated from 0 to b, right? Now that is equal to 3b. All right, now fundamental theorem of calculus says go ahead and plug in b and then plug in 0 and then subtract them. So if I plug in b, I'm going to get 2b minus 3b squared minus b cubed, all of that, minus, now plug in 0. It's always good to show that you actually plug stuff in. So I know minus 0 is kind of silly, but I'm showing I plugged it in, equals 3b. And now I can actually go ahead and solve this, right? So I'm going to get everybody on the same side. I don't like my b cubed negative, so I'm going to move that over. So how about 0 is equal to, I would have a b cubed, I would have a plus 3b squared, and I would subtract 2b, so I would have just plus b equals 0. And now I can solve this, and apparently there are 3 different answers for b that would make sense here. So let's see. If I factor out a b, I think I would be left with b squared plus 3b plus 1. And so one answer is b equals 0. And the other answer, well, that's kind of silly, right? If I went the interval 0 to 0, it's probably not going to have that much of a value. So that seems like a silly interval. That's not even an interval. It's not moving at all. But that would have been one answer if it made sense. Now, what about the other answers? Well, that's a quadratic formula right there. So good thing we know quadratic formula, or if we could factor it, that would be great, but we can't. So b is equal to the opposite of b, negative 3, plus or minus, that's a different b, right? B squared, which is 9 minus 4, a times c is 1, all over 2a, so all over 2. And that looks like negative 3 plus or minus root 5 all over 2, which is what? Negative 3 over 2 plus or minus root 5 over 2. So there are my other 2 answers. Now those 2 answers for you are, that's negative 1.5 plus 5 over 2. Now 5 is what is, I don't know, what do you want to call that? 2 point something. So that's pretty good. And the other one's negative. That's probably pretty good. So those would be my 2 answers, right? Over that interval. Now, oh wait, no, that negative one doesn't make sense. I can't have negative 3 over 2 and then minus, right? That wouldn't make any sense, because the only reason it wouldn't make sense is because I'm going from 0 to something. I wouldn't have a smaller number b on the right. So it appears the only answer I see is negative 3 over 2 plus root 5 over 2. Now, all of those could have been answers, but that is the only b value that I see working in this problem, because of the fact that the negative one would have been more negative, and that wouldn't make any sense, and 0 isn't really an interval. So there were 3 times that this interval was equal to 3, but only one of them actually made sense in being an interval. And that, my friends, is kind of fun. Those are equations using integrals. So let's try example 2. Example 2, now look at that, from -5 to x, they're not even messing around with us anymore. They're like, from -5 to x, I want you to find that equation when it is equal to 0, and tell me what x value that is true for. All right, same kind of thing. I am going to figure out, first of all, what this is. So this is, what do you want to call this? X cubed, oh, we got to integrate, right? I got to integrate this, so I'm going to integrate from, I'm going to integrate, what is it? Go up a power and divide. That's 1/4 t to the 4th minus, go up a power, minus 7 over 2 t squared. And that gets evaluated from -5 to x. And I want to figure out when that is equal to 0. All right. So go ahead and do that. I'm going to plug in an x. I'm going to get 1/4 x to the 4th minus 7/2 x squared. And then all of that minus, when I plug in a -5, and that is going to be some huge number. How about -5 to the 4th? Same thing as 5 to the 4th over 4. Minus 7 over 2, that's 25. So 7 times 25, I believe, over 2. So there's that. And now I'm going to have to go ahead and figure out what that is. In this case, when is that equal to 0? 7 times 25, that's not quite 8 times 25, not quite 200. So that is just shy of 200, or what, 175. Well, anyway, let's look at what this is. This is 1/4 x to the 4th minus 7 over 2 x squared. Probably should figure out what that is. 25 times 25, isn't that like 625 or something like that? You want to make sure? 25 to the, wait, wasn't it 5 to the 4th is 625. Yeah, that's what I thought. So that would be 625. So minus 625 over 4 minus, and what did we say that was? That's 200 minus 25. So 175 over 2 is equal to 0. Now, I do not like all these numbers, all these fractions. So what if we multiply everybody by 4? What would we get? We'd get x to the 4th minus 14x squared minus 625 minus 350. Oh, big mistake there when I dropped the parentheses, did I not? Right? That was minus that first one, but then minus a minus, so that's really plus. So caught that kind of early, makes me feel good. This is x to the 4th minus 14x squared, and that's what, my 275. So plus 275, no, minus 275. And if that equals 0, then I can and factor that, or I could also try to quadratic formula it, whatever. Well, let me see. I think it's like x. I think 25 is going to go into x. Notice it's x squared because this is x to the 4th and this is x squared. And as long as that first term is double the middle term, then we know the factors are going to be x squared. I think it's 11 and 25. Not because I'm a genius, but because I remember doing this already. So x squared plus 11 equals 0. And so we have two answers. We have x equals 5. We have x equals -5 from the first two. And then this one, subtract 11 and square root, that's going to be imaginary. So those aren't going to make any sense. And so when does the integral equal 0 for that? Well, apparently it equals 0 when x is 5, or -5. Kind of makes sense, because if you go from -5 to -5 and you add up what we have nothing, because we haven't really done anything over the integral. So that one kind of makes sense. And we also have it again happening at 5. So that is kind of interesting. If we graph this, it might be kind of cool to see where that is. If you had a graph, and maybe I encourage you to graph it on your calculator, but I imagine it looks probably something like this. And we're going from -5, say, which means all of this area. When does all of this area cancel out? And so it's finding all this area. When does that look like 0? This looks like this is kind of more negative than that is positive, say. So it won't happen again until it gets all the way over here at 5, where all of these areas cancel out. And so that's kind of neat. And so there you go. There's an equation that you have solved very nicely. So again, you can do that one, and I will be right back after you've figured that one out. All right, feel free to pause the video and see what you see on part B there, but there was quite a bit of work, and if you want, I can kind of walk you through it, but I did integrate like we would expect, and then I did clean it up, and then I got it down to here, which I bet most people did, and then we said, uh-oh, how are we going to factor that? That's not something that's that easily factorable. And so I went synthetic division, and I tested -3 in synthetic division. Why? Because I knew that this, I kind of understood that this summation, this net accumulation, was going to equal 0. So one way it would have to answer is go from -3 to -3. There would be no value. There would be no accumulation there, right? So if I did that, I knew that had to be an answer, and I plugged it in, and lo and behold, guess what? It was an answer. It gave me this leftover right here, and then I took this leftover, did the quadratic formula, and found the other two answers, and then just kind of for my amusement, I graphed it. So I said, all right, it kind of looks like this, and there'd be some area here, and then probably get canceled out somewhere about here. That must be the negative version. And then I said, okay, to keep getting negative areas, and now it's, way negative, the entire net accumulation. So not until I started picking up some more positives did it get another one, so that's probably the other one. And so I made 3 answers make sense. -3 where there's no accumulation, and then when it finally balanced out 2 other times, and then after that it's just going to keep getting positive, so it'll never hit it again. So I was like, okay, I feel pretty good. So that was a pretty neat little problem that we did there. All right, example 3. I give you this guy, and we're going to try this. Going to have to take a break because this thing's going to cut me off. But I don't want to go too long, so let's try anyway. Okay, no, we're going. All right, here we go. This is kind of a fun problem because it gives you f prime, which is the rate at the y's are changing at, but then it gives you f of 0. So kind of putting everything back into it. Let's find a particular solution to the equation and evaluate x equals 2. So they give you the derivative, and they say f of 0 is 5. What's f of 2? So one easy way to do this would be to say that, well, if you gave me the derivative, then if I integrate that derivative, I should have f of x, right? So there you go. I have my f of x, and I'm going to go ahead and integrate that. So first, I'm going to integrate that. I'm going to find the general solution. So f of x is equal to, now notice we have no endpoint, so that's why it's going to be a general solution. Go up power and divide, 2/3 x cubed minus 2x and plus c. And there you go. We have the equation. Now to find, this is what we call, remember, the general solution. And so now I want to go ahead and find the particular solution by plugging in this point right here. So if you tell me that y is 5 when x is 0, I get, oh my gosh, c is 5. So I can say when, what's the point? When f0 is equal to 5, then f of x is equal to 2/3 x cubed minus 2x plus 5. And now when they want to find f of 2, I can say, all right, so f of 2 is equal to, now that would be 2/3 of 2 cubed is 8, minus 2 times 2, which is 4, plus 5, which is 16/3 plus 1, or 19/3. And there you go, there's f of 2. Now look at part B. Is there another way? I didn't get to use a calculator, I didn't get to do anything there. I actually had to know how to integrate. What if that wasn't something that was integratable? That would be a really tricky question. And is there another way to do this? And the answer is yes, right? The answer is part B. It says using a definite integral. So what is it? Well, what this was, right, the way you get something is you take what you started. Just think of anything in life. Whatever you have right now is where you started and then what you got from there on out. So if I started with, 2 cars, and then and then over time I've accumulated 3 more cars.